So this is Jack Kavanagh doing the first CA for maths for year 2 computing. For the first question, we have an object that's moving in a straight line at a constant speed from the point minus 13 when time is equal to 0 to 11:17 6 seconds later. So the first thing we have to do for this is to get the equation of the line, and the first thing you need for that is to get the slope. So just a simple equation for slope is y2 minus y1 all over x2 minus x1, and when we work, so it will be it will be y2 minus y1, so it's going to be 17 minus 13, so 17 plus 13 all over 11 minus 1, so it's 30 over 10, which is 30, or 3, sorry. So then we just use y minus y1 is equal to x by x minus x1, and that works out at giving us the equation y is equal to 3x minus 16. So that gives us the base equation for the line. Now, to make this into a parametric equation, we're going to have to incorporate time, which is where we're going to change x, where x is equal to t. And to incorporate time, we have to see how fast it's moving as well, and it has to go from the point 11 to the point, the point 1 to the point 11. So that is a distance of 10, and it has to do it in 6 seconds, so that is going to give us 10 divided by 6, which roughly works out at 1.67. So it's going to be moving at 1.67 units per second. So what we're going to do to the equation then is sub in this here with t. So we take we'll end up with for y or the y of t being equal to 3 multiplied by 1.67 t plus 1 minus 16, and the x of t being equal just to 1.667 t plus 1. And then what we do, we graph that over 6 seconds. So we sub in 1 to 6 or 0 to 6, and we get this graph here showing it starting at 0 seconds at the point 1 minus 13 and finishing after 6 seconds at the point 11:17. It's slightly off because we rounded off 10 over 6 to be 1.67. Now for the wave type motion, what we were given that we want the object to start at 7,6. The center of the radius is 0,6, and the center of the circle be 0,6, and we want it to have a radius of 7. So to make a standard circle, we use, let's have a look. Yeah, it's just this here. We use sine and cosine. So if we just had a sine wave, this here is going up and down, and then it's the same with the cosine wave going in the opposite. Oh well, very similar. But if we graph one of these, it will just be going back and forth between 1 and 2 in the x, or in the y, it'll be going up and down between 1 and 2. So, but when we do both of them together, it's going to give us that angular motion. So that's what gives us the wave, and then that's what gives us circular motion. Now to get the radius, it's going to go by standard between 1 and minus 1, or y1 and minus y1. Y minus 1 and y1. To get that, all we have to do is put a number in front of it. So this one here goes between minus 1 and 1 and 1 and minus 1. If you put 3 in front of it, it goes between 3 and minus 3, minus 3 and 3. If we do need to change the center at all, where is it? All we do is we add the number on where we want the center to be. So so we'd say like cosine, like let's say we just want it to be radius 1. So we just have cosine t minus 3 to put it at the back here, and then sine plus 2 to bring it up to. So that just gives us where we want the center to be. To control the speed, we go into the actual sine and we multiply it by what we want the speed to be. So let me have a look. I have a good example of that here. Yeah, here. So here is a sine wave moving at normal speed, and it's just giving us a normal circle, and that's over 10 seconds. When we multiply t by 2 inside of the sine, we can see that in 5 seconds we get the exact same output as we would on this one, because it's moving twice as fast. All the points match up identically, but for half the amount of time, because we made the speed to be 2 units per second rather than just 1. Now, when we want to change the starting point of the motion, what we do is, to change the x coordinate, you go like, so for this one, we go like 1 plus that, and then for this one we'd add it on after. I think that's the right way around. Yeah, you add the number on before the sine. So adding the number on before the sine will give you the actual the first starting point. So now, just to get the direction, all you have to do is flip around the sine and the cosine positions. So here, for example, we have the cosine first and then the sine second. Then we have the one of these. Yes, this one here. We have the cosine first and then the sine second, but you can see that oh crap, I've lost it. Sorry. Yes. No. Yeah, if you flip around the sine and the cosine, yes, it's this one here. If you flip around the sine and the cosine, so you have the cosine first and the sine second, then you have the sine first and the cosine second. The first point you can see is 5, 0. So that would be, so it would start here, then it's going around this way, while this one is starting here and going around this way and this way. All you have to do is put the sine first and then the cosine, so this one's going anti-clockwise and then this one heading clockwise. Sine first gives you clockwise, cosine first gives you anti-clockwise. And that is everything then. Just for this one, so we wanted it to start at 7. We needed the first point to be 7, 6. So we obviously just moved it over 7 to give it a radius, and then we put it up 6 as the first point, giving us here. So we added the 6 on in front of the sine. Then to give us the starting point, the center of 0, 6, we just had to move everything up 6 as we already did, and multiply it by 7 to give us the radius as 7 on both sides. And then the time is 4, so we multiply by 4 to give us the actual speed, and then we just get it over 90 seconds, and that is that.